Thank you for joining us for this Siemens Solid Edge webinar that focuses on how to manage large assemblies. This is part of a series of webinars that discusses how your company can undergo a digital transformation, speeding your product development and manufacturing process and helping to ensure the products you deliver to your customers are world-class. I'm sure you are aware of Siemens, one of the largest manufacturing companies globally. For more than 165 years, Siemens and its customers have been pushing the boundaries of manufacturing technology. Today, Siemens is a recognized industry leader in digital transformation for design and manufacturing organizations.
But let's first take a moment to talk about the evolution of manufacturing. Most of us are familiar with the previous industrial revolutions that have brought us to the 21st century. The first was mechanization using water and steam power in the 18th century. The second was the introduction of mass production using assembly lines, for example for Ford's Model T in the early 20th century. And the third, the advent of computer-controlled machines and robots in the 1980s. At Siemens, we believe we are now witnessing the beginning of a fourth industrial revolution. Advancements that enable a digital transformation, adding intelligence to digital models throughout the product lifecycle, connecting these products to each other and their manufacturing processes, and indeed to their whole value chains and business models, enabling manufacturing organizations of all sizes to take advantage of the industrial internet and become digital enterprises. This digital technology is leveling the playing field for businesses of all sizes, including small and medium-sized businesses, enabling them to disrupt their industries. It's creating opportunities to develop products and services that were once inconceivable. Size, which was once a competitive advantage, is becoming a liability as businesses that once dominated their markets are now struggling to keep up with young, nimble startups. This digital transformation is helping companies make their processes leaner, faster, and more flexible, enabling them to rapidly evolve to react to ever-changing market requirements and conditions. Siemens focuses on several areas where we bring our expertise in the fusion of the virtual and real worlds for product development and manufacturing. The Siemens Digital Enterprise Software Suite enables effective, sustainable solutions for all industrial enterprises that wish to embrace and shape a digital transformation. Some of the key elements of this suite include, for example, digital product design and simulation, lifecycle data management, manufacturing control systems, and automated drives. The Solid Edge portfolio is focused on driving digital transformation for small and medium-sized manufacturing companies. We see that these manufacturers want complete, fully featured professional engineering tools, but they also need tools that are easy to access and easy to learn. As you will see in this webinar series, the Solid Edge portfolio is much more than Solid Edge 3D CAD software. It is a complete portfolio of solutions for design, simulation, manufacturing, and technical publications, together with tools for collaboration and data management, that together speed the complete product development process and help ensure the delivery of world-class products to your customers. With the Solid Edge portfolio, you can create detailed 3D digital models of your proposed products and use this as the basis for all areas of product development, including concept and detailed design, prototyping, simulation, manufacturing, installation, and service. And this 3D digital model helps SMB manufacturers address trends like increased complexity and increasing regulations. My name is David Chadwick, and I'm your host for this webinar. I'm also joined by Kevin Grayson, who is our presenter for today's topic of managing large assemblies.
Thank you, David. Before we get into the actual demonstration, I wanted to at least mention that one of the key things when you are working with larger assemblies inside of Solid Edge is obviously keeping track of the hardware that you have, and that includes the amount of memory, the speed of your CPU, and obviously having a professional graphics card. You'll see a website listed at the bottom of the page where you can check out the testing of different graphics cards to see if the one that you're using is going to work well within Solid Edge. Obviously, as you look here, the amount of memory you have is critically important. The more you have, the better, especially when working with larger assemblies. The faster your CPU, the better, and then also having a really good graphics card. The focus of the main demonstration is going to be talking about the ease of accessing the data that you want to work in, and that goes both for the assembly models themselves as well as the drawings. We also want to talk about how you can work more efficiently with the tools that are built into Solid Edge, primarily by optimizing your display with built-in tools like display configurations, being able to utilize tools such as simplification, and then also things like zones where you want to work with inside of a spatial area. Some other key things that will help you, which we won't go over too much in the demonstration itself, but being able to turn off some of the visual effects like reflections, shadows, and then changing some of the options with some of the options in the View tab, such as calling the sharpness of your display and how your views transition. And then we'll also talk a little bit about how you can maximize your memory usage by utilizing some tools such as unloading hidden parts and then inactivating parts that you're not currently working in. With that, we're going to go into Solid Edge and talk about some of these tools. The specific assembly that we're working in, this is a plant layout, and you'll notice as I zoom out, we have a number of components here, both from the plant design as well as the shop floor. As I pull up the statistics of this particular assembly is about 12,500 components. And as you look here, some of the statistics that you see representing some of the different components as far as their count for the different components. But then you'll also notice that this particular assembly's total document size is just under 700 megabytes. So we are working with a very large assembly in this example. I also want to talk a little bit more about some of the built-in tools. We talked initially in the PowerPoint about accessing this data quickly. So one of the things I want to show you before we get into some of the ways that you can optimize your display is how you can access large assembly files very quickly. So I'm going to open up this same plant layout file and show you a way that you can access it almost instantaneously. You'll notice inside of the Solid Edge options menu, we have some tools that allows the user to specify what exactly is a large assembly. So large assemblies to different customers can mean different things. It's basically a relative number. You'll notice under the options for opening up the assembly, I can specify what represents a small assembly, in my case, 100 parts or less. A medium-sized assembly, 100 to 10,000. And then also here representing 10,000 or more components is what I deem a large assembly. And what that means is as we open up components or open up these large assemblies, we can specify some different criteria. For example, I may want to open up the assembly file itself, but not display any of the components. So you'll notice in this case I have the option for yes, for hide all the components. Again, I'll talk about the benefits of that here in just a minute. We also talk about activating parts that I might want to work on, or maybe keeping parts inactive if I know that I'm not going to work on those components. Keeping parts inactive means that I can display them on screen but not have them loaded into memory. So that will increase the efficiency in which I work. We also have simplification tools. I can specify when I open up large assemblies that it opens up in a simplified state. And then same thing for subassembly options. When I access a large assembly file, you'll notice here that you have the ability right down here as one of the options to open the assembly as, in this case, large assembly. And you'll notice that it's going to open up this file almost instantaneously, even though we're accessing over 12,000 different components. One of the benefits that Solid Edge gives you is it gives you access to the structure of this particular assembly. And what you'll notice is as I hover my cursor around different components, it highlights exactly what components and where they are within that specific plant layout. So for example, if I know that I'm working within the specific area of this large assembly, I can highlight those components and choose just to show them. And that gives me access to those specific components where I don't have to sit and wait for all of the 12,000 components to load on screen. And I'm sure many of you who are on this call today have probably accessed a larger file at some point, hit File Open, and had to sit and wait for all of those components to load on screen. This is one way that you can work more efficiently in gaining access into this large assembly. We'll go ahead and close this specific file down. We'll go back into the previous assembly where all of the components are displayed. And I just want to talk a little bit about some of the built-in tools that allow you, again, to work more efficiently by optimizing your display. Oftentimes, too, when you're working within large assemblies such as this one, you don't really need to see many of the smaller components. I don't really need to see nuts and bolts and washers and maybe some of the other options there. I may just want to focus in on some of the main machinery or maybe some of the other main components. We have built into Solid Edge a tool called Select Parts by Size. And you'll notice here with just a couple of clicks of the button, it's going to start accessing the parts based on their size. And if you look closely here, you'll see that we've got a number of smaller components highlighted, again, in just a matter of seconds. If we look down here at the metrics, it shows that I've selected over 3,500 components in just a matter of seconds. And what I may want to do is just hide those. So again, being able to select those very quickly and then being able to hide those very quickly, I'll just do a right mouse click and choose to hide them from the screen. And that way, that's going to, again, increase performance as I'm working inside of a larger assembly. We mentioned being able to access or maximize your memory usage. We also have a tool here that allows us to unload hidden parts. So those parts that I just hid, if I want to unload those from memory, what that'll do is that'll speed up other assembly tasks because those parts are no longer in memory. So it gives me, it gains me better efficiency as I'm working within the larger assembly because now those 3,500 components are no longer in memory. Another way that you can maximize your display or increase your efficiencies is also to utilize what we call display configurations. Now obviously if I've been tasked to work within a certain area of this particular plant layout, I may have some other members of my team working on other areas. So we may be accessing this top level assembly and working within some of the different sub-levels. I may just want to look at specific components. So I may want to just, in this example, look at the floor layout. This may just show some of the specific machinery while turning off the building structure, maybe the water towers on the outside, and allow me to just focus in on what I need to see. So what display configurations allow you to do is focus in and create what we call saved views, and allows me to gain access to specific components without having to come over here on the left-hand side and manually hide and show those components. I can save them and get access to them very, very easily. As I zoom in on one of the areas of the floor layout, you'll notice that we have some machines that are represented in great detail, and then we have others that are represented with a more simplified display. And again, this is a way that you can optimize your display and gain efficiencies as you're working within these large assemblies, is by creating what we call simplified versions of the assemblies. Another nice little feature we have is being able to access where in the Pathfinder over here on the left-hand side a component might reside. Obviously, if we have 12,000 components listed on the left-hand side, it may become difficult to find exactly what I'm looking for. So what you'll notice is as I select a part graphically, what Solid Edge will automatically do is scroll to where that part resides in the Pathfinder. So it'll highlight that component as you see here, and then show me the different levels, such as sub-assemblies that component resides in. In this case, I'm going to open up this particular sub-assembly and just show you some ways that you can create a more simplified version. You'll notice right now we are looking at the designed version. If I just tag it to simplify, this will gain me access to different tools that will allow me to very quickly create that simplified version. We have all of our modeling tools available, so you could choose to just model the shape of the simplified version of your assembly, or an even quicker method would be to utilize this tool called enclosure. What enclosure allows me to do is to enclose the area that I specify, in this case with a box. And I'll just specify the outer regions or the outer components, and Solid Edge will do the rest for me. It'll create a box around the outer extremities of the components that I selected. Now we have the option for a box. We also have the option to do what we call a cylinder. So components that you see like this may be better represented as a cylinder. And Solid Edge again will model that for me automatically. I can also do the same task between multiple components. So for example, if I select two different components, Solid Edge will create a cylinder between those two areas and just simplify this area for me. If we look down here on the bottom of the machine, you'll see that we have several feet. In this case, we have about 7 different feet. I'm going to simplify one of these, and again, we'll let Solid Edge do the rest for us with the other 6 feet. We have a nice tool here called Duplicate Body. That'll allow me, if I've simplified one of those components, it'll go through and actually find all the rest of those for me, and then create the same simplified part on the rest of those. Again, decreasing the amount of time that I have to work to create the simplified version. For purposes of time, we won't do anything else to simplify this. I just wanted to show you a couple of the tools there that allow us to take a more detailed assembly and create a simplified version of that. So we'll go ahead and save that. And as we come back out to the top level assembly, you'll see how we can access whether or not we want to display the simplified version or the designed version. And this will take us back out to the top level assembly, and I'll show you here in just a second or two how we can gain access to which version we would like to display. So again, all I do is I come over here to where the subassembly resides, and just by simply doing a right mouse click, you'll see an option in your shortcut menu that allows you to say use simplified assembly or use designed. And we'll tag the simplified version. Again, that'll show us what we just created. And again, it cleans up the display. We don't need to see all that detail, and again, allows us to work a little bit more efficiently within this larger assembly. And we talked a little bit about display configurations earlier. Display configurations, as I mentioned, is just a way that you can show and hide specific components and save that view so that you can get back to that view at any point in time. If you look in the display configurations, the symbol here for holding tanks looks just a little bit different. This is what we call a zone. And a zone is very similar to a display configuration, but it's based on spatial area versus just components that are hidden or shown. So I'm going to show you in this example the holding tanks zone, and it's only showing different components that reside within that spatial area. And what I'll do is I'll show you with a box what that zone looks like. So again, another way that you can access different components if you maybe work within a specific area of a larger assembly is you can create a zone, and you can also open up the assembly based off of a zone. Very similar to what I did when I hid all the components initially. I can open it up based off of a zone and open up and get access to this file much quicker. Just to show you a real quick example, you can modify the spatial area that you're working in. If I select the zone itself, you'll notice that it's showing all the components inside of that zone. If I want to modify that, I can simply just pick on any one of these zone faces. And in this case, maybe I'll push that front face in just a little bit. And what you'll notice here, now that the stairs and the person that are standing on those stairs are now outside of the zone, as soon as I click Show Components, it'll turn off the display of those specific files because they no longer reside inside of that zone. Zones are also dynamic, so as you're working and modifying your assemblies, if you add additional components inside of this spatial area, they automatically get added to the zone. Or if you move components outside of this spatial area, they automatically get removed from the zone. So it's just, again, a quick way to show components based off of spatial area, make you very efficient. Again, since we're working within a large assembly that contains, over 12,000 parts, sometimes you may need to find components based off of property information. And we have a nice tool here called queries. I may want to create a query and find all of the components that are in our packaging area. So we'll create a query, and I want to find anything that has packaging in the category. So that'll create that here. Again, I just simply double click on the query. It'll show me graphically which components those represent, and I'll do a show only to show only the components inside of the packaging area. I'll also turn on the factory floor just so we can get a little bit better feel for where all of these components reside. Some other tools that are really nice within the assembly environment, being able to not only assemble parts together, but also being able to replicate components, is being able to find, again, where components reside inside of the Pathfinder, being able to find those very easily, and how Solid Edge will scroll to those. But I also want to show you this nice handy tool called our steering wheel, which allows us to either manipulate the position of a component, or we can also replicate parts very easily as well. As soon as I select a component, you'll notice up here in the top portion of the menu bar is we can select to copy that machine. So for example, as I'm trying to lay out all the different components within the shop floor, I may want to replicate this machine multiple times. I simply just hit copy, and then which direction do I want to copy that machine? So very quickly I can grab an entire machine, create a copy of it. I can key in values to specify exactly where that machine is going to go. In this case, the number that I typed in was a little bit too small. I may want to redo that again and copy it maybe a little bit further out. So again, let's go through. We'll grab that machine. Missed a 0 on that. I typed in 200 versus 2,000. So again, just to show you how easy it is, we'll select that we want to copy that in this direction. And this time let's type in the appropriate number. So maybe 2,000 millimeters towards the right. And we can do that several times. So maybe I want to copy both of those and get 4 of these total. So I may want to go through and not only select the one that's selected now, but also grab this first one as well. So we'll select both of those. Again, we'll utilize the same steering wheel tool, and we'll copy those out. And now we'll create 2 additional machines, and that'll fill up that space a little bit better. I can also take any of these machines and manipulate them, as I mentioned earlier. Maybe this one here on the end, maybe I want to push this out. Again, I can just move it versus just copying it, and maybe we'll move this out, maybe 4,000 millimeters, and then maybe just rotate it into position. So again, instead of utilizing the directional arrows, I may select the steering wheel itself, maybe rotate that out 90 degrees. And we can go through and just position this very easily without having to use assembly relationships. One thing we may also want to do, as I mentioned earlier, we may have several team members that are working inside of this plant layout. oftentimes as you have multiple people working on the same file or working within sub-assemblies that are related to the same top-level assembly file, oftentimes you may want to limit exactly when a file gets saved or updated. And Solid Edge has some nice tools that allow you to specify whether or not you want an assembly updated automatically when somebody else makes a change. And we have controls that allow you to do just that with updating the assembly as well as saving it. We also have a nice component tracker here where when files get changed, again, maybe my team member's working on a different area, while I'm working in the top-level assembly as well, I can also check and see which assemblies or which components are out of date. And I may want to go through and see which ones are out of date and choose myself if I want to update or save those components with this nice handy component tracker. So we've talked about the 3D assembly. I also want to show you some tools that are available when you're working with large draft files. And you'll see here as I open up the draft document of this factory, when I click on the file itself, again, just to show you the size, this is a 70 megabyte draft file. And just like I showed earlier, gaining access to the 3D model very quickly, we also have a tool called Inactivate Drawing Views so that I can open up this large draft file in a review state. And again, just like with the 3D model, I can open up this large assembly drawing very, very quickly. It's almost instantaneous from selecting the open button. So you'll see on the first page, I have a page that shows the entire plant layout. Maybe I have a couple of other pages, maybe showing the shop floor layout, or maybe specifically one of the individual lines. And even though these views are inactive, I can still do things like place dimensions on the views. Maybe I need to get a distance between these two machines. And I can go through and place dimensions on the views and get some information out without having to load all of these views into memory. So again, it allows me to open up the files quickly, still do some work that I need to do, but I don't have to, once again, wait for the views to load into memory and wait for the file to open. I want to show you another example here of opening up an even larger assembly, and for purposes of time, we'll go through this relatively quickly. But this particular assembly that you're about to see has over 2 million components. So again, Solid Edge does a really good job of working with these large assemblies. This document size is extremely large. And again, as I mentioned, it has over 2 million components, but it's basically a cruise ship built to scale. And you can see if you utilize the different tools that we talked about here in this webinar, you can work with extremely large assembly files. As you can see here, the performance is really good in terms of view manipulation and being able to work within different areas of the assembly itself. And then just as a last thought here, if you go to the Solid Edge website, if you go into the assembly area, you'll see highlighted over here, if you go into Solid Edge Design and then Solid Edge Assembly Modeling, we have some additional resources that you can go download. And again, some different tips for working with large assemblies inside of Solid Edge. There's 2 different documents here that you can download and review, and it'll kind of reiterate the things that we talked about in this webinar, as well as give you some additional information. I would highly encourage you to go to the website following the webinar, download this information, and once again, figure out some really efficient ways if you are working within large assemblies. With that, I'm going to go ahead and turn it back over to Dave, and we'll wrap up the webinar from here.
Okay, thanks Kevin. Certainly some really great techniques there for working with really large assembly files and large draft files as well. So thanks a lot for that, Kevin. Just a few final notes from me. If you'd like to find out more about Solid Edge, you can call this number to speak to us directly. Or you can also go to this link here and download a trial version of Solid Edge that you can use for free for a period of 45 days. And also just a reminder that you can attend any of these upcoming webinars. You can attend them live or get a replay of the webinars that we've captured so far. just use the link in your WebEx interface or look out for the emails from Siemens, which have the information about these webinars. You can see we cover a lot of different topics here, so hopefully there's something else of interest for you in this list. So at that point, I'd just like to thank you all for joining this web presentation and enjoy the rest of your day.